All right, so this one you can solve with either quadratic formula, you can solve it with completing the square, or you could solve with factoring if it's possible. Factoring isn't always possible. Factoring is the easiest method by far, so if it does factor, that works out the best. However, I'm just going to go ahead and do completing the square for this one. So let's go ahead and do that. So completing the square, I write it out as 2x squared plus 3x plus blank equals -5. So I put my, 5. I was thinking it was on one side, I had to go to the other. All right, so I went ahead and put a space here, and the first thing I'm going to do is I'm going to divide everything by 2. Because the first step for completing the square is that you need this x squared expression, you need the coefficient to be 1. So that's why I chose divided by 2. So you end up get x squared plus 3 over 2x plus here equals 5 over 2. Okay, so now this blank is just whatever this one is by the x divided by 2 and squared. Okay, when I divide it by 2, that's what's going to be in my factor. So I'm going to have x plus 3 divided by 2 is going to be 3 over 4 squared. That's what that's going to be. And this is what's going to go in the blank if I square this. So what I did, 3 over 2 divided by 2. So just look over here. So 3 over 2, look over here. Divided by 2 is the same as 3 over 2 times 1/2, which is 3 over 4. So that's where I got the 3 over 4 from. Now squared, I'm going to square 3 over 4, and I'm going to get 9 over 16. So that's going to go, squared is going to be 9 over 16, but what I do on one side, I have to do on the other. So I'm going to add 9 over 16 here. So I have x plus 3 over 4 squared, and then I'm going to have 9 over 16 and 5 over 2. So look over here, and let's go ahead and solve it. 5 over 2 is the same, so I have it plus 9 over 16. 5 over 2 is the same as multiply by 8. 2 times 8 is 16. So what I do to the bottom, I have to do to the top. 5 times 8 is 40. So 40 plus 9 is 49 over 16. So I have this is just 49 over 16. So I just added 5 over 2 plus 9 over 16 to get 49 over 16. Okay, so now this is squared. So what I'm going to do is I'm going to take x plus 3 over 4. I'm going to find the square root of both sides. And the square root of 49 over 16, square root of 49 is 7. 7 times 7 is 49. And square root of 16 is 4. But it's plus or minus because remember, a negative times a negative is going to get you a positive, and a positive times a positive gets you a positive. So that's why I have 2 answers here. So finally, to get the 2 answers is you're going to subtract 3 over 4. So you have x equals negative 3 over 4 plus 7 over 4 and negative 3 over 4 minus 7 over 4. So this is going to get you negative 3 minus negative 3 plus 7, which is going to be 4 over 4, which is 1, and negative 3 minus 7, which is negative 10 over 4, which if I simplify that, that's going to be negative 5 over 2. So these are my 2 answers. Remember that the solution, what that means, solution means, when it crosses the x-axis. So that means at 1 and at negative 5 over 2, which is negative 2.5. So that means that my parabola looks something like this, and it goes through 1 and negative 5 over 2. So that's what it means to have a solution. So if you had a graphing calculator or something, you could put this in here and find out where it hits the x-axis. All right? Okay, composite functions. For f of x, I have f of x equals 1 minus x. For g of x, I have equals 4x squared plus x plus 6, and it wants me to find f of g of x. So to find f of g of x, remember what I do is I'm going to put my f, which is 1 minus x, and instead of x, I'm just going to do that. So that's what that is. F of x is 1 minus x. And what I'm doing is everywhere that I have an f, I'm going to put my g in there. So I have 4x squared plus x plus 6. So we're just going to solve it. And so all that does is this subtracts everything inside of here. So that's going to be 1 minus 4x squared minus 1x minus 6. So the 1 and the 6 are the only like terms that can combine, and therefore come on down here, and I get negative 4x squared minus x minus 5 is the answer. Okay? G of f of x. Now it's opposite. Now I'm going to write g out. So g, remember, is 4x squared plus x plus 6. So I'm just going to write 4 instead of the x. I'm going to just put a parenthesis like that. Plus, again, instead of the x, I'm going to write a parenthesis. And then plus 6. And in the parenthesis, I'm just going to write my f equation, which is 1 minus x. 1 minus x. Okay, so this is, remember, order of operations says I have to square first. So I have to do a little bit more work on this one. So I'm going to do 1 minus x times 1 minus x. So 1 minus x times 1 minus x is 1 minus x squared. And if I do that, I get 1. And this is going to be minus 1x. I have to do this one, minus 1x. And then plus x squared. So now I have 4, 1. This here is going to combine to negative 2x minus 2x plus x squared. Now I'm going to go ahead and finish up this back part, and I get plus 1 minus x plus 6. Excuse me. Distribute the 4 in. 4 minus 8x plus 4x squared plus 1 minus x plus 6. And now we're just going to combine all the like terms. So I have a 4, and I look for a 1 and a positive 6. So just add those up, and I get 4 plus 1 plus 6 is going to be 11. And then I have negative 8x and a negative x, so that's going to be minus 9x. And then I have a positive 4x squared. So this is not written in the correct order because you always want the highest exponent first. So come on over here, and you can see the answer is written in the correct order, and that's 4x squared minus 9x plus 11. Okay, the next one is f of g of 2, and then g of f of 2. Let me tell you the easiest way to do that. The easiest way is, remember, this first one here was my f of g of x, which is another way to write it. And so all I'm going to do is I'm just going to put a 2 in for the x. So I'm going to have 4, negative 4, 2 squared minus 2 minus 5. So just a very simple problem. Remember, order of operations tells me I have to do that first. So I have negative 4 times 4 minus 2 minus 5. So this is going to be negative 16 minus 2 minus 5, which is minus 7. Negative 16 minus 7, which is going to get you negative 23. Thank you. Got some help. Negative 23. Okay, so the next one's the opposite one, g of f of 2. So for g of f of 2, you are going to go ahead and put the 2 into this equation that I've boxed in red. So I'm going to show the work over here. So that's just going to be 4 times 2 squared minus 9 times 2 plus 11. Again, I just replaced the x with the 2. So here we're going to do 4 times 4 minus 18 plus 11. 4 times 4 is 16 minus 18 plus 11. If I add that up, 16 minus 18 is negative 2 plus 11 is, here we go, final answer is 9. Okay. All right, let's flip on to number 4. Use the vertex and intercepts to sketch the graph of the quadratic function. Given the equation of the parabola's axis of symmetry, give the equation of the parabola's axis of symmetry, and use the graph to determine the function's domain and range. Okay, so axis of symmetry is just x equals negative b over 2a. That's all that is. Now, that's not your answer. That's just your general equation. So where do you get the b and the a from? If you remember, is that I have this as a up here, x squared plus bx plus c. So the number before the x squared is my a, the number before the x is my b, and the last number is my c. So move on down here, and I see that 1 is a, so a is 1, b is 6, and c is 8 in this case. So if I do negative b, so I have negative 6 over 2 times 1, that's going to get me negative 3. So the axis of symmetry means this. That means I'm going to go over here to negative 3, and I'm going to put an imaginary dotted line. And what this means is my parabola is going to be folded on top of this. So if I have a point on this side, it's going to have a mirror image on this side. Okay? What's the domain? The domain is asking, what can I put in here? And so for all quadratic functions, it's always all real numbers, or negative infinity to positive infinity, all real numbers. Because there's no x that's restricted. You can put any x in there that you want. That's all it's asking. Okay, so the range. I think the easiest thing to do for the range is to go ahead and graph this. And so if so I need to at least have my vertex point. So I have my A, and so if I know my vertex is on my axis of symmetry, I just don't know where the point is. So if I take my -3 and I put it into my equation, that will give me whether it's where this is on this line. So let's put the -3 in here. So I get -3 squared plus 6 times -3 plus 8. So -3 times -3 is 9 plus -18 plus 8. Add those together and I end up getting -9 plus 8, which is going to be -1. Okay, so I know at this point right here is my vertex. And because this is a positive x squared, I know that it opens up. So I know this is not gonna be an accurate drawing, okay? We don't need it to be completely accurate at this point, but I'm just gonna kind of show you about what it's gonna look like. This is gonna give a pretty close example to what it looks like. My whole point is that it is going to be opening up, and this here is my lowest point, and that's what I need to know for my range. That's all I need to know, because that's gonna be my lowest point, okay? And for my lowest point, that means my range is going to be at -1, and it's gonna go up forever, and so that goes to infinity, and that's how you do it, okay? Okay, let's look at number 5. Okay, we have the following is given, and now we have to list all the possible zeros according to the rational zero theorem. So the rational zero theorem is just this, plus or minus p over q. This number here is p. And this number here is q. All right? So p over q, what p is, it's all of the factors of this number, and q is all of the factors of this number. So if I list all the factors, I get 1 times 45. I get 2 doesn't work. I go into 3, and I say, okay, 3 works. So 3, and I say 3 times, I put this in, and I get, if I put in here, I go like this, and I say 3 goes in 1 time, minus 3 is 1. So I say 3 goes in here 5, so 3 times 15, right? So I look here and I say 4. Does 4 go in here? No. Does 5 go in here? Yes, because we have 5 times 9. And I go, okay, does 6 go in here? No. Does 7 go in 45? No. Does 8? No. Does 9? Oh yes, we're at 9, so then we can know we can stop. So positive, plus or minus all of these go into 45. So these are considered my P. So all of the factors of 45 are my P, and all the factors of 7 are my Q. Well, 7's easier because we just have plus or minus 1 times 7. So literally, this is what I do. Okay, I'm going to go 1 over 1, 45 over 1, plus or minus 3 over 1, plus or minus 15 over 1, plus or minus 5 over 1, plus or minus 9 over 1. Then my additional ones are plus or minus 1 over 7, plus or minus 45 over 7, plus or minus 3 over 7, plus or minus 15 over 7, plus or minus 5 over 7, plus or minus 9 over 7. So obviously all the different combinations. So look on down here at my choices. Okay, and my choices, if I look at C, C encompasses all my choices. Okay, all right, synthetic division. Use synthetic division to test several possible answers. So we're going to have synthetic division, and it says, so on Math Excel, sometimes it says, okay, well, let's see what we're going to have. So I'm going to tell you that we're going to start here. So we're going to start, and I'm going to go ahead and choose. I'm kind of cheating here because I know 5 over 7 works, but honestly, you could use anything that you think can work here. But if I used 5 over 7, for instance, that's one of the answers.